Hola. This week's assignment has to do with managing project risk. And we're going to talk in this podcast about some of the basic concepts of risk management. And then I'm going to go over the template that you'll use for this assignment. The first thing I think we need to do is to understand the basic concept of risk. As usual, I would suggest that you read the Verzoo book. It's got a very good chapter on risk management, and also the supplemental reading also has a very good section discussing many of the same concepts that I'm going to be talking about over the next few minutes. But the first thing we need to do is define risk. I think we all have a basic understanding of the idea of risk, but let's be very specific. Risk has to do with uncertainty. It's about events that may or may not happen. If something is certain to happen, it may be a problem, but it's not a risk. Risk is about things that may or may not happen. In other words, it's about uncertainty. Okay, I think this will become more clear as we go along, but it's really not a very difficult concept to understand. Let's talk about the process that we use to manage risk, especially during the planning stage of a project. Essentially, risk planning has four stages. The first is risk identification. The second is risk documentation. The third is risk analysis and prioritization. And the fourth is risk response planning. Let's go through each one of these one by one. The first is risk identification. The first step in managing risk is to find out what the risks are. Now we first talked about risk when we were doing the project charter, and there is a section in the charter that asks for a few high-level risks. And most of you put in one, two, three, or four risk, which is, quite satisfactory for that particular document. But we're going to get much more detailed now that we're doing a full-blown risk analysis in preparation to plan the project. So the first thing we need to do is to identify the risks. And what we do is generally we get the team members and other stakeholders, people who are knowledgeable about the project and the environment within the project situation, and brainstorm potential risks. The question becomes, well, how many risks do we list or do we identify? And there is no simple answer to that. Every project is subject to thousands of risks. That's the bad news. The good news is most of those risks are very small. That is, they're unlikely to occur. If they do occur, will probably do negligible damage to the project. But there are some that out there that are likely and could have a significant impact on the project. And it's important that we identify those risks. And that's the purpose of the risk identification stage of this process. So we gather the team members, the various stakeholders together, and we brainstorm. Um, some project managers find it useful rather than just trying to brainstorm project risk to break it down into categories. So, for example, we could brainstorm the technical quality or performance risks. And when we complete that, we can talk about, well, what are the project management risks, or organizational risks, or external risks? It really doesn't matter how you do it as long as you come up with a good set of risks at the end of the process. The second step, once we've identified these risks, is to document them. And to do that, we have a form. In fact, it's the form that you're going to use for your assignment this week. In other words, it's the project management risk template. And I'm going to go over that and show you how we document the risk. Here we are. You can see in the first column we have a list of numbers. In the second column, we have the risk event, and you're going to enter the risk events in this column. Presumably you will have 20 or more. It's a minimum of 20. Then the third column has a P at the top of the column. That stands for probability. And you'll notice I've entered values in for each of the 5 risk events that I've put in here. The first is server fails, and I put a probability of 5. Now these probabilities are expressed as percentages, so that would be 5%. Server is hacked would be 1%. Requirements delayed would be 35%. And programmers not able to program features would be 10%. Okay? So even though they're written as numbers, keep in mind that they're actually percents. The range is going to be somewhere from 1 to 99. Why not 0? Well, if the probability of a risk event occurring is 0, then it's not really a risk. Remember, risks are things that might happen. If it has a 0 probability, then it won't happen. There's no uncertainty. And the same is true about 100. If something is absolutely certain, that is 100% certain to occur, then, as I said, it's a problem, but it's not a risk. So our probability scale goes from 1 to 99. Now the impact scale is a little different. We can go from 0 to 100 here. 0 being no negligible or no tangible damage to the project, and 100 being absolutely devastating to the project. And intermediate scores represent different levels of impact. The RPN column, and RPN, by the way, stands for risk probability number. That's simply multiplying the P and the I together. So 75 times 5 becomes 375. 1 times 90 is 90, and so forth. So that gives us then our RPN. And the larger the number, the greater the risk. So when we're done, what many project managers like to do is to sort on the RPN with the highest numbers at the top and the lowest numbers at the bottom. And that way you can see which are the greatest risks for this particular project. I'm going to suggest that maybe we do something just a little bit different in just a moment, but that's certainly a very viable way to approach the risk analysis form. I haven't entered anything into the responsibility, but most of these events are going to affect one or more work packages. And so I think it's a good idea to put the name of the person who's responsible for that particular work package. Now, server fails might affect actually more than 1 or 2 work packages, but to the extent that it's localized, put in the name. I mean, think about it for a moment. If you were working on a project and a particular failure mode occurred that affected your work package, the one you're responsible for, wouldn't you want to know that? Or if you were working on a work package that had a high probability of failure, in other words, it was very risky, wouldn't you want to know that? So let's put in then the name of the responsible person wherever it's possible to do that. The next column is cost increase. And this is where we're getting into some analysis now. Remember I said there were 3 stages. We talked about risk identification, risk documentation. Now we're getting into the area where we're going to be talking about analysis and prioritization. If the server fails, how much additional will the project cost to complete? That's what we're going to put in this column. So in other words, what we're saying here is that if this server fails, it's going to cost the project an additional $12,000. It's going to be $12,000 more expensive to complete the project if the server fails. If the server is hacked, it's going to cost an additional $35,000 to complete the project. And if the requirements are delayed, an additional $10,000, and so on. Now, that's assuming that those things happen. We know that these are risks. They might happen, but they might not. So what we're going to do is we're going to try to estimate the cost increase based on our risk analysis. And to do that, what we do is we multiply, okay, the cost increase times the probability. Now remember, although it says 5 there, that's 5%. So 5% of 12,000 is $600. And likewise, we get 1% of 35,000 is 350. And 35% of 10,000 would be 3,500, and so on. And you'll notice that we total those at the bottom. So what that means is that we, in addition to the known costs of the project, the additional risk factors are going to add an additional $6,950 to this particular project. And we should budget for that because that's our best guess as to what the project is ultimately going to cost us above and beyond the budgeted amount. You know, the reason why projects go over budget is not so much because we're bad at budgeting the work in the WBS, but these risk events involve work that's not in the WBS. This is above and beyond. So we're actually pretty decent at budgeting for the work that we know we have to do, but we oftentimes don't budget for the work that we don't know we have to do. That's essentially what this tool does. Is it's telling us how much the work we don't know we have to do will cost us. At least it's an estimate. Okay? And in this particular case, it's $6,950. Okay? Now we can do the same thing with the schedule. These are budget items, but we can do the same thing with the schedule. We can say, for example, that if the server fails, how much delay will it cause the project? And we can say, well, it will cause 21 days of delay. Or if the server is hacked, how many additional days will it take to complete the project? Well, it's going to take 30 days. That's our estimate. Now remember that we have Slack, and so we're looking primarily here at critical activities or activities that are delayed beyond the available Slack. But the 21 days, the 30, 14, and 42, that all assumes that the risk event does actually happen. And of course, as with the budget, we know that it might happen, but it might not. So we're going to do the same thing. We're going to take the 21 days and we're going to multiply it by the 5%. And that's going to give us 1.1. And then we're going to take the 30 and multiply it times 1%. It's going to give us 0.3. The 14 times 35% gives us 4.9 days, and so on. And now we look down at the bottom and we see that based on these risk events, we can expect an extra 10.5 days to complete the project. Now often what we do is we put a buffer at the end of the project, and that buffer is the amount of schedule risk exposure. That way, when the project is delayed by some of these risk events, what happens is that we eat into that buffer rather than delaying the completion of the project. Now you'll notice that there's the fifth risk event. I didn't enter any numbers in for it. Well, weather is going to be a risk factor for a lot of different kinds of projects. The problem is, how do you deal with weather? Well, first of all, what's the probability? The probability of weather is 100%, right? There's always weather. The issue is what kind of weather. And that's where weather is too broad. What we need to do is, rather than put in weather, we need to put in something like hurricane or thunderstorm or high winds or something very specific, because otherwise we can't calculate the probability or the impact. So, and there may be more than one weather-related risk events. So, when you're putting down your risk events, make sure they're specific. If they're too general, you're going to have a hard time coming up with probability and impact. It'll also be difficult to determine your cost increase or your delays. So be specific about that. Okay, now we have one more column to fill in, and that has to do with action. Okay, what I would suggest that we do at this point, I think earlier I had suggested we sort on the RPN number, and that will give us our biggest risk, which is requirements delayed at 875, followed by programmers not able to program features. These are the largest risks because, first of all, this one is particularly likely to happen. Although server is hacked has a very, very high impact, its probability is very, very low, so it has a low RPN. Well, if we said every project is subject to the triple constraints: time, cost, and scope. Not all of those are equally important. I think we talked about this in our one in-class meeting. For every project, there is generally one of those three constraints that's most important. It might be time, for example. If time is the most critical of the constraints, this is a project that absolutely has to be done on time, then what I would do is I would sort on delays so that the risk that has the potential for causing the greatest delay is at the top and the one with the least at the bottom. That's your priority. See, the thing is that we don't have the resources to be able to deal with every risk. So we have to pick out the ones that are going to do the most damage to our project. And if the driver of the project is time, then we need to sort them on the delay. On the other hand, if cost is our driver, the most important of the three constraints, then we're going to sort on cost. And you'll notice that if cost is our project driver, then our biggest risk is going to be requirements delayed. On the other hand, if time is our driver, then the biggest risk is going to be programmers not able to program features. And so we have to determine our actions and our priorities based on that. So let's look at the last column. The last column asks us for an action. Now, essentially, there are about 4 different kinds of actions that we can take. The first is what we can call avoidance. In other words, we can avoid that particular risk. It's not possible to avoid all risk, and there are some risks that simply can't be avoided. Let's say, for example, the server fails. How can we avoid that? Well, we may not be able to avoid it. We may have to take some other kind of action. But certainly what we can do is we can buy the finest quality servers and configure them and operate them in such a way that they are not likely to fail. That might be one action that we can use, but technically that's not really avoidance. Let's take an example. Let's suppose, for example, that we're constructing a building, and we have one of the risk events is say hurricanes. Well, we could avoid hurricanes as a risk event if we build during a time of the year when they don't occur. That would be an example of avoidance. Or sometimes in IT projects we can use a different kind of technology to avoid a particular problem. So avoidance is one way in which we can deal with a risk event. But remember that avoidance probably costs money. And so what we have to do is we have to see if the server fails, it's going to cost us $12,000 in addition to the known costs of the project. So whatever action we take, if it's more than $12,000, it's probably not cost effective. Okay? So if it costs us more than $12,000 to avoid server failing, then that's not a viable option. Okay, so we've talked about avoidance. That's that's the first one. The second one is what we would call mitigation. Mitigation is a term that you don't hear used very much. Basically, mitigation means to limit. And in this particular case, we're talking about limiting the damage that it would do. So, for example, let's say that we're concerned about the server failing. We've already determined that avoidance is too costly. So maybe we can mitigate. In other words, we can minimize the damage. What if we had a backup server? Okay, so that if the server fails, we're only down for a very, very short period of time and then we're back up and running again. So the amount of damage that's done will be very, very minimal. And instead of an impact of 75, maybe we'll have an impact of 4 or 5. Now, if we can get a backup server for less than $12,000, then that sounds like a good alternative. Okay, so we've got avoidance and we have mitigation. A third one that we can use is called transference. That is where we transfer the risk to somebody else. And this is one that a lot of people don't think about, but let me give you an example. And this actually happened. For a number of years, I was the director of a nonprofit organization, and one of the things that we did each year to raise money was to hold a golf tournament. And I was, by default, the project manager for the golf tournament. Well, golf tournaments are a good way of raising money if you can get people to play. So you have to entice people to play by offering them certain prizes, for example, the opportunity to play on maybe a course that they otherwise wouldn't have access to, and so on. Well, we thought, what if we could offer a prize for anyone who hits a hole in one? And so we thought about maybe a $10,000 prize. That was one option. Another was a Harley Davidson motorcycle, which is worth actually quite a bit more than $10,000. The only problem with that is, I mean, the chance that somebody would hit a hole in one is very, very small. Okay, but what if they did? We don't have $10,000 in the bank. We couldn't pay them, and this golf tournament would no longer be a money raiser, but it would be a money loser. So we couldn't afford to do that. So there is an option, and that is that we bought hole-in-one insurance. I didn't even know such things existed. But for $350, we were able to buy $10,000 worth of hole-in-one insurance. And what that means is that if somebody hits a hole-in-one, the insurance company pays them $10,000. It's no longer a risk for us because it can no longer do any damage to the project. We paid an insurance company $350 to take the insurance, to take the risk for us. You can probably think of a lot of examples in construction, for example. We have bonding and insurance and all kinds of other things. So transference of risk is not a novel idea, but and it doesn't work for everything. But there are certain types of projects where transferring risk can be helpful. And the last is what we call acceptance. In other words, basically, we simply say if it happens, it happens. There isn't anything we can do about it. Now, there are two types of risks that we accept. Risks where it's too expensive to take any action. Okay, too expensive to avoid, to mitigate, to transfer, and so we have to accept it. The other type of risk event is one where the probability is extremely low and the impact is low. And there are going to be thousands of these risks. They're not likely to occur, and if they do, they'll do very, very little damage, so it's not worth even considering them. So we simply accept them. Okay? So now when you're filling out this template for your assignment, indicate what action you would take. And it's got to be one of those four options: avoidance, mitigation, transference, or acceptance. Okay? Well, I think there's other things that you can do. For example, with this form, I've seen it extended out so that you actually develop a budget